So here is another podcast from the consideration of how humans impact the planet. We are talking about climate change, climate science, and yet the Earth system should be considered as a natural human system that's interacting with each other, and human activities have created global warming, and we are climate change, and we are discussing mostly that. But there are unintended consequences of even trying to solve the problem of climate change. If you look at future of how carbon drawdown has to happen to meet our targets of 2 degrees C or 1.5 degrees C, something called BECCS, bioenergy, carbon capture and sequestration, shows up as one of the inevitable solutions that we will need to employ among the portfolio of solutions. And this is just a brief introduction to how bioenergy can actually have unintended consequences. Of course, you probably can think that when you start using grains for biofuel like ethanol additives that are mandated in the US, then under certain conditions like droughts, it can begin to have competition with the food market, food prices, and affect mostly who? The poor people, right? So let's run through a few things from a nice article in The Conversation, which is another good outlet, by the way, which publishes very good articles from scientists and others with very balanced views. The US burns about 17 billion gallons of biofuels yearly, roughly 5% of overall liquid fuel used for transportation as of 2019. So there is ethanol as an additive that was mandated way back when, and biodiesel, which is much more of a direct fuel. So you can see that the use of ethanol as an additive has exploded and has plateaued, or maybe has dropped a little in 2020, but that's 2019, but that may be because of other issues. So because the biodiesel also drops here. So what are the consequences? Look at this Twitter handle saying prices of ethanol have surged, rekindling a debate about whether it's contributing to pain at the pump and whether the White House should relax ethanol blending regulations. As American gasoline prices soar, some blame ethanol. So the ethanol addition has been, so this here announces contains up to 10% ethanol, and you can see there are various grades here. And the question is, when drought comes, grain production suffer. I think in 2011 drought, the crop yields of corn went down tremendously, but there was no change in the requirement for ethanol addition, which means obviously either the price at the gasoline pump had to go up, or corn had to be imported if a lot of the ethanol came from corn, as it does in the US. So one can also think about life cycle analysis for greenhouse gas balances. If you look at conventional fossil fuel, you have crude oil extraction and pre-treatment, transport for processing, refining, conventional fossil fuel coming out of it as petrol or diesel, and then used in transport and of course other things, which leads to greenhouse gas emissions. When you think about life cycle analysis of liquid biofuel, on the other hand, to grow it, you're already doing land use change, which leads to greenhouse gas emissions. And there is feedstock production, land, fertilizer, pesticides, seeds, machinery, fuel, and so on. Transport for processing, biofuel processing, enzymes, chemicals, ethanol, biodiesel, and co-products, and then used in product transport. So there is greenhouse gas production along almost every step of the production here as well. So it's not a question of whether it emits less overall, but in the life cycle analysis, how does it contribute? So looking here at reductions in greenhouse gas emissions of selected biofuels relative to fossil fuels, of course you have a big gain. Let's say sugarcane in Brazil can provide you 70 to close to 90% reduction in emissions. Second generation biofuels, palm oil, okay, can range from 50% reduction to over 80%. Sugar beet, European Union, rapeseed, maize, maize in the United States of America. So you can see that this is not much of a reduction. So then you have to be really careful about the other things like land use, pesticides, water quality degradation, soil erosion. There is also consequences on deforestation and so on and so forth. We looked at several of such information infographics from Our World in Data. This is showing food crops, greenhouse gas emissions across the supply chain. So goes from land use change, farm, animal feed, processing, transport, retail, and packaging. So you can see that palm oil and soybean are right up here. Compared to rice, rapeseed is better, sunflower oil is better. Soybean is also used in tofu, cane is also used for sugar, groundnuts, and so on. So you can see that the overall greenhouse gas emissions in the life cycle sense of considering all the steps is another big concern. So we don't need to just assume, we shouldn't assume that just because it is biofuel, it is environmentally more friendly or overall more beneficial than fossil fuels. So land use for vegetable oil crops across the world from the 1960s to 2018, you can see palm oil is beginning to increase and has had some grave unintended consequences in places like Indonesia. Soybeans have now become bigger and bigger part of the oil crops. Sunflower has remained fairly steady after increasing, rapeseed, and then you have others like cottonseed, groundnuts, coconut, and so on. Okay, so here is an infographic from the Union of Concerned Scientists, which says we need tropical forests and we are losing them to palm oil, but we can fix it. So let's first look here. Tropical forests preserve biodiversity and help slow global warming. So tropical forests and others, of course, biodiversity is critical. The question again is, how do we value it? It's a non-market good. This challenge is always important, and you remember how people can tinker with the discount rate and reduce the value, for example. Tropical forests store 271 billion tons of carbon, 7 times as much as all fossil fuel emissions in 2008. But tropical forests are being cut down for palm oil over a rapidly expanding area. Average annual land use carbon emissions from palm oil in Indonesia 2001 to 2010, 216 to 268 million tons. That's equal to emissions from 45 to 55 million cars. 85% of the species lose their homes when this happens. So when pristine tropical forests are converted into palm oil plantations, 85% of the species that live in them lose their homes. Okay, there are other details here. We started with 14.5 million tons of demand for palm oil, which has now grown in 2020 to 75.6 million tons. That's a pretty massive jump there. So this is the number here. Total land cultivated for palm oil went from 15 million acres in 1990 to 40 million acres. So obviously it's a zero-sum game on the planet. This land increase of plantations have to come from somewhere, and it's often coming from deforestation. How to fix it? Deforestation-free palm oil is possible, but it'll only happen if we demand it. You may not think you buy much palm oil, but it is in thousands of products we use every day. This goes into this carbon trap we are in. You may want to do a lot of things as an individual, but the system is trapped in in a way that pretty much anything you buy throughout the day, throughout the year, is going to have things that you don't know where it's coming from and what it is. So you can have often very little control on what choices you have. Find out all you can how you can help preserve biodiversity and slow global warming. So go to this site by the Union of Concerned Scientists. The other side of the story is also for soybean. Deforestation made Brazil the world's top soy producer. So if you look at soy production over Brazil, USA, Argentina, and China, from 1980s to the more recent times, a couple of years ago, just about last year, there is US increased quite a bit as well. The Argentinian production seems to have plateaued. This is China, which also has plateaued. China consumes a lot of tofu as, soybean as tofu as well. So here is Brazil mostly commercializing soybean as a cash crop. Total amount of Brazilian Amazon rainforest lost since 1970 is 792,051 square kilometers. Of course, not all is going to soybean, but you can bet that soybean is a big part of this deforestation drive overall. There is, of course, massive production of sugarcane, timber, expansion of human habitats, and so on. So this is not good news. Does that mean we need to stop biofuels? Of course not. What I'm saying is that life cycle analysis often becomes necessary for everything we do, and even when we think we are putting up solutions like biofuels with carbon capture and sequestration, which would make it very carbon friendly, and yet we cannot look just at the end of how much fossil fuel emission is reduced by using biofuels. We have to look at how the biofuel is produced, processed, transported, and what land use changes are involved in producing it. Okay, so just keep that in mind as not a direct consequence of climate change, but a response of human beings to try to solve climate change and then creating unintended consequences. Okay, complicated, but very, very important to understand nonetheless.